Thanks, Jess. Good afternoon, everybody. I'm really excited to be joined today by an amazing panel to discuss this topic. I want to introduce firstly Tamara Quinn. She is a data privacy and intellectual property partner at Osborne Clarke. Richard Stirling, he's the CEO of Oxford Insights. Mikael, the Executive Director of Assessments and Insights at the Banking Standards Board. And finally, Haitham Ammar, Head of Reinforcement Learning at Huawei Technologies Research and Development UK. I'm really pleased that they could all be part of this discussion today. It's been wonderful the past few days hearing the incredible speakers at CogX 2020 talk about how we can get the next 10 years right. There have been many discussions about the advances of artificial intelligence and the many different potential uses for AI. We want to take that one step further this afternoon and discuss how do we govern all these uses of AI? And more specifically, whether it's the ethical considerations about a decision, the safety of the models, or the transparency of an outcome, we want to explore and discuss the limits in the use of artificial intelligence to replace human judgment around ethical considerations about what is right and what is wrong. We're going to start off with a presentation by Haitham. He's going to frame the discussion by speaking about machine learning towards an ethical framework and how a machine learner can certify another learner. But before he starts, I want to give you a bit of background on Haitham. Haitham currently leads the reinforcement learning team at Huawei Technologies Research and Development UK. Prior to Huawei, he led the reinforcement learning and tunable AI team at Prowler.io, where he contributed numerously to their technology in finance and logistics. Haitham did his PhD in artificial intelligence at the University of Maastricht, and he currently holds an honorary position at UCL. Haitham, I'd like to hand the floor over to you.
Awesome. Yeah, thanks, Chuck. Hi, everybody. Right, so let's get started. So first of all, I'm really super excited to be here discussing this topic. I really think this is one of the most important topics that we ought to be talking about, especially in this day and age. And what I will be talking about is an ethical framework to machine learning. And before starting, I would like to say that to me, an ethical framework is a framework combining uncertainty certifications, robustness certification, safety certification, fairness, authenticity, accountability, privacy, security, and so forth. So to me, all this umbrella falls under ethics for machine learning. Now, there's a big hype around machine learning today where people are somehow equating machine learning to deep learning. One of the goals of my topic is to actually say that this is not true, and machine learning is not just deep learning. Deep learning is just one tool. So let us start by understanding what machine learning is as defined by Professor Tom Mitchell from CMU. So Tom said that a computer program, so we have a computer program, and that computer program is going to learn from some experience E, which is your data set, like, for example, my face images and so forth, with respect to some task T, where the task here corresponds to like a classification task. It can be a control task. It can be a prediction task in a stock market or so forth. And some measure P, which is like a classification error or a generalization error. We say that this computer program is learning if the performance measured on that task T, so if the classification error improves with more experience. So as we get less and less error with more experience, then we say that the machine learning algorithm is actually working or learning. Now, machine learning can be split into three broad fields. The first is supervised learning, where in supervised learning, we're given a labeled data set. So for example, I give an image of a bike and I tell you that's a bike. I give you an image of a car and I tell you that's a car. And now your goal is to design some sort of a model, a classifier, where you input a new image and then that new image will tell you, oh, that's a car or that's a bike. So that is supervised learning. On the other hand, we have unsupervised learning where we're given an unlabeled data set. So I don't give you labels. I just give you a data set and I ask you to find me some interesting patterns. So for example, I might be asking you to be able to find some communities in a social network and so forth. And the third is reinforcement learning, where in reinforcement learning, we have an agent that interacts with an environment and its goal is to find the optimal action selection route. These are the fields of machine learning. And as you see in all what I've discussed now, I didn't even mention the word deep learning once, other than saying that deep learning isn't really machine learning. Deep learning is just another tool in the machine learning workshop. There's nothing, it is nothing more than that. It is not that machine learning equates to deep learning. It's just another tool. Now, this definition has led to tons of awesome applications in the real world, from cooling systems to self-driving cars to logistics, computer games, search and recommendation, which all of us use, smartphones, applications in medicine, robotics, and so forth. So it enabled a new generation of awesome applications. However, with all these progresses, machine learning has still a long way to go. And the reason is, by a simple search around the internet, you come to understand that machine learning is full of biases and assumptions that do not necessarily reflect something good in the real world. So, for example, there's a software called Compass being used in the US in order to predict the future of criminals. And it turns out, as after an exhaustive study done in 2016, that this software is actually biased against African American people. Similarly, Amazon has scrapped its AI recruiting tool because it turns out that it is biased against women. And now this is interesting. So, we train our conv networks, we get 99% accuracy. We're super excited about that. But then in a study that was performed, it turns out that you are very high in predicting. If you are a white man, the model can actually predict correctly that you're a white man. But if you are an African American lady, then this accuracy drops down to 35%. And many other examples, including maybe a one that had a lot of buzz, was the Microsoft one, which was silenced, the chatbot from Microsoft, which was silenced after it kind of became racist through training through Twitter. So now clearly, these are big problems that are there in machine learning. And what is good is that companies are taking action. Big companies are taking action, not ignoring them. So, for example, Amazon is scrapping things off, similarly Facebook, similarly Microsoft, and similarly us at Huawei. And also, we are investing a lot of money in order to try to crack these problems. So now, if we are to create an automated framework that tries to assess these types of biases and ethical problems inside machine learning, there are two questions really we would like to answer. The first is, okay, how are we going to design that? And what things are we going to look for to certify inside that framework? So this is a standard machine learning framework that goes from data collection to data cleaning to feature extraction. And then you have your deep learning model or some other machine learning algorithm, and you have predictions. So here you collect your data, here you clean it, you make sure it's all right, and then here you extract your features, and then you train your model. Then you get your predictions, and these predictions are typically fed back to each of these steps, where you try to improve each of these steps such that you maximize your predictions. Now, this is where the problem starts, honestly, because nowadays research in machine learning is really just interested in trying to get classifiers that give you lower error, trying to get reinforcement learning algorithms that give you better behaving policies. But that's the only type of considerations we really are interested in today. And I don't think that is enough to be considered. We should consider more things related to ethics. So the way I propose to create a framework is an architecture that introduces a new agent or a new certifier, and that certifier can actually diagnose and query each and every step of this process, of the standard machine learning pipeline, and then actually flag or even later on autonomously correct for some of these problems in each of these steps. Now, interestingly, this certifier can be phrased as an instance of a well-known game theoretic principle, which is like two-player games, where this certifier and this pipeline are playing together some sort of a game, where the certifier tries to query certain points or certain aspects of this pipeline, and then the pipeline responds back, and then the certifier tries to improve whatever biases occur in this generation process. Now, of course, you might ask, okay, so good, that's how we can do that, but then how are we going to architect that certifier, and how are we going to get that certifier to work whatsoever? And now stay with us, because these are some of the most interesting questions we're going to be discussing in our panel. But now let us talk a little bit about what to certify. So what notions should we certify inside a machine learning pipeline? So things that pop to mind are things including uncertainty, which to me is very close to transparency. A robustness, whether this model that we created, this data collection process, is going to be robust with respect to changes in the data. Is it safe? Is it fair, accountable, privacy? Is it private, and is it secure? Now, It's important to note that this is not a philosophical argument I'm making here. We actually instantiated this framework inside some applications in Huawei that I'm going to tell you a bit more about. But before going there, let me describe for you a little bit more what I mean by uncertainty, robustness, and safety. Fairness, accountability, and so forth will be also discussions we will have during our panel. So stay tuned. So, when it comes to uncertainty or transparency, it is very important for the model to give me calibrated error bounds, telling me how sure the model is about its predictions. So for example, this is a result from a paper that used convolutional neural networks to make a classification of images. And then what you saw here is that this convolution network, when you give it an image that looks like this, it turns out that it's trying to predict that it's a number 4 with high certainty. However, we all agree that this is not a number 4. So the point is that it's not only important to give me a point estimator, it's not only important to give me how good my model is, it's also good to tell me how sure my model is about its prediction. And why is that important? Well, simply if it was a self-driving car, we don't want it to predict that this is a rock and not a human being and not be certain about that prediction. So what we really need is we really need to, focus less on new architectures that give me tenth of percents of improvements over current methods, and actually try to see how we can make models transparent through an uncertain kind of quantification process. The other one is I would like these models to actually test for standardized hardware. And because the reason for that is if we don't test for standardized hardware, then it might be that the model is unbiased on one hardware, but it becomes highly biased on another hardware. And here's an example from reinforcement learning, whereby you want to train this cheetah robot in order to walk forward. And now this is a good behavior by reinforcement learning. However, reinforcement learning also believes that this is an equally good behavior for a cheetah robot because it's still moving forward, right? But it's definitely unsafe. In fact, deeper studies have shown that the performance of methods varies a lot across different hardwares. So if we are to certify these solvers, we need to make sure that these certifications happen across the board, across different hardwares, because it's another topic we will discuss in our panel, because it's really important to understand who will we hold accountable here. Is it the designer of the algorithm? Is it the GPU manufacturer? Who is it? Moreover, we would like to test for efficient solvers. And now, why do I mention efficient? Well, I mention efficient for two reasons. The first one is because I do not think it is very ethical or fair across the scientific community for people to spend trillions of money trying to solve some computer games, as long as we do not care for its implications on the environment, its implications on where that money would have been spent as well. Here's a study we did in my team, and we realized that, for some solutions to be scalable of these methods, we require about $1 trillion in budget, which is the total budget of hardware in the last year. So that's reason one. The other reason also relates to the efficiency, relates to robustness. And why do I say that? Because these models are highly inefficient, so I cannot apply them to the real world. And then what I end up doing is I end up building simulators. So there's two directions to go. I'm not going to discuss model-based because of the lack of time. I'm going to focus on simulators. So the idea is that when you design a simulator, you hope that whatever you design still transfers back to the real world, i.e. you want things to be robust. Unfortunately, in these results here, again conducted by my team, we came to realize that current models are highly non-robust upon minor attacks or minor changes to the dynamics in the environment. So these plots here are just heat maps, and the more the red, like the darker the red, then the higher the reward, the better the performance. And the X and Y axes represent different variations we can make to the dynamics of the system. And now what you can see is that upon minor variations of the dynamic of the system, the performance deteriorates horribly. So things become really, really bad. What my team was able to achieve is something that deteriorates still a bit, but along these lines. So we're working on these types of metrics to certify these types of robustness. Finally, and this will be discussed thoroughly in the panel as well, we need to test for safe solvers. And in safe decision-making, we try to split this in the community into two phases. The one is called a safe learning process, and the other one is called a safe final model. So during the learning process, are we safe? And is the final model after deployment safe? So here we need to ask questions such as how viable is, randomly exploration? How transparent is the learning process? How explainable what can we say about the explainability of the learning process? What about the data? Maybe the data is super biased. That's also not good. Is the system accountable? Is it secure? Is it fair? So all these need to be answered. And in the case of safe final models, the question is, okay, if we deploy our models, are these models safe? And are the models safe on data that we do not see, like we haven't seen before? And this is important for machine learning because the whole idea is to generalize beyond seen data. And when do our models fail? And how likely is it? We need to quantify things like that. And in case of unsafety, can we recover? As well as how to formally verify AI systems. Now, interestingly, these problems need valid definitions. Like the community is still struggling to get valid definitions that answer each of these questions. And that's why I think these problems are extremely important. So this involves both theoretical and engineering challenges, and we need metrics for ethical and safe AI. So in Huawei, we tried to study some of these problems, and then we created a solver that is capable of reducing the number of faults during a safe learning process, as well as guarantee a safe final evaluation or safe final controller in our case, as we deploy the model. So these are comparisons against different algorithms from literature. So for you who know, TRPO is cross-region policy optimization, PPO is proximal policy optimization. And then what you can see is that for these to learn, they require a lot of samples, and they go to areas which are unsafe, very highly represented by TC, which we call total cost of going to an unsafe region, TV, total number of violations in going to that unsafe region. We also evaluated and saw that our method can actually meet constraints such as different types of flexible constraints. So what we're doing is we're devising a framework that can test safety and robustness to adversaries and uncertainty of machine learning decision makers. We are trying to efficiently learn safe policy with reduced number of visits to unsafe regions, as you see here. So our method is called Samba. As you see here, we have this reduction in terms of the number of visits to unsafe regions compared to others. And we also acquire safe final controllers, as I showed you here with these check marks. And we support flexible notions of safety, as well as we empower transparency because we use probabilistic model and we quantify uncertainty. And it can be framed as a two-player framework I just described above, what I call the certifier proposition. So we can use this to have different considerations, including considerations arising from model and data biases. Now, this all in all would create a framework that will actually give us a radar chart which certifies each and every aspect of the AI system or machine learning system, and it will allow me to understand if this system is actually ethical or not. Is it safe or not? Is it robust or not? Before going from a lab idealization to a real world, I firmly believe these steps are very, very important as they enable ethical frameworks. So to end, I would like to say that what I have presented is just the start. It opens the discussion. I really believe that through a diverse and collaborative effort, we can envision ethical learners. I do not think that it is enough for AI engineers to do that on their own, as I do not think that social sciences can do that on their own. I really call for a diverse and collaborative effort between these different fields for us to crack these hard but exciting problems. Thank you. So Chuck, I think I'll go back to you now.
Apologies for that. Thank you, Haitham. Appreciate your presentation and the concept that you talked about in terms of a certifier proposition, in terms of uncertainty, evaluating uncertainty, robustness, safeness, fairness, accountability, and privacy. Those are really important and contentious items about whether or not we can utilize AI to assess those factors. And when I look at it, it really comes down to a judgment in aspect in terms of the definition of these factors. And the question that really springs to mind is, actually, do we believe that we can automate the judgment and the human judgment components in defining what is fairness or what is accountability or what is privacy? I want to bring the other members of the panel into this discussion and have them number one, introduce themselves, but then weigh in on the topic and asking them to share where on the spectrum are they between never or always. Can we automate, human judgment factors like ethics, robustness, safeness, fairness, accountability, and privacy? Why don't we start with Richard?
Good afternoon. Thank you very much for that talk. So I'm Richard Stirling. I run Oxford Insights, and I mainly work with governments advising on AI policy and implementation. And my personal take on where I stand on this spectrum between can you automate some of these judgment decisions, like some of the all the time or never, is kind of towards the always end of the spectrum, but with a little bit where I think human judgment is needed. Because if you think about those factors we've just heard, like a number of them, you could imagine tests which were like a clear this bar and maybe we'll look at you. But if you fail to clear this bar, then you're definitely not okay.
Tamara, what about you? What do you think?
Hi. Well, good afternoon. As was mentioned, I'm a partner in a law firm, Osborne, Clarke, based in London. And I specialise in data privacy and intellectual property. So I'm also part of our AI team, and I'm especially interested in areas of intersection of data privacy and IP, which is obviously very relevant to the AI context. So just to stress, I'm a lawyer here, not the technical person. So I'll probably live up to the lawyer's reputation here and say, I think it depends. I mean, it depends what sort of judgment we're talking about exercising and what we mean by exercising judgment. But in this context, obviously, we're talking mainly about ethical frameworks and ethical decision making. But perhaps surprisingly, even to myself, I think I'm further along the spectrum towards you can always use automation to make these decisions than I would have thought. So I guess if there's a spectrum here with never use automation for these systems at one end, and you've got always at the other, I'd say I'm probably somewhere past the midpoint. So just to be clear, I mean, I'm not saying that existing AI systems are capable of making what might be regarded as ethical decisions at the moment. They may be. I suspect not many are, but I think we've got to look to the future, and it seems to me quite unlikely that at some point in the future, which might not be very far in the future, we're not going to have AI systems that are at least going to be able to perform significant parts of this decision-making process, if not always the final decision.
Let me bring Mikael in and get his perspective.
Thanks, Jack, and good afternoon, everyone. As Jack mentioned, I'm Mikael Down, Executive Director at the Banking Standards Board. I'm also doing my own research as part of a multidisciplinary PhD on AI and ethics. So these are issues to think about a lot, and there are certainly no easy answers to them. I mean, I think in looking at the role, and I was really interested in the model that we were just discussing and the basis for that. I think in deciding what you want to automate, I mean, first of all, you've got to maybe unpack how humans take decisions, right, and how humans make ethical judgments. And there's about sort of 2,500 years of literature on this, so we're probably not going to do that justice in this session. But I think there are kind of three kind of main components to this. So I think I was reading a piece of research recently that found that we take around 35,000 decisions every day. So how do you identify which of those decisions are significant and need have some kind of moral or ethical component to them, which then requires some proper thought and consideration? So we as humans have developed basically shortcuts and heuristics to be able to do that, but it really relies on our ability to reason. And our ability to reason is something that we acquire through our lives. We don't suppose that children have the ability to reason, for example. Certainly they don't. They aren't seen as agents in the eye of the law, because they don't have the cognitive powers, they don't have the experience. We don't suppose that animals have the ability to reason. So we set quite a high bar for having an ability to reason and therefore provide an ethical, identify what's worthy of ethical thought. And that's a kind of non-trivial step to go through. Once you've done that, of course, you then have to have the will to act ethically. So I might identify something as an ethical action. I might decide that actually, rather than rushing to get my train, not at the moment, to get to an early meeting, I want to stop to help somebody take their an elderly person take their shopping bags back to their house who I've seen is struggling. That's a decision that I take. I have to want to take that decision. And the third aspect of it is I have to have the freedom to act once I've decided I want to do something. So you can possibly look at, whether different aspects of that kind of whole calculus around ethical decision making can be automated. In terms of where I kind of think about this, I think on the kind of human, on the willing side of it, we are all very biased. We've talked a lot about human bias in the context of this conversation, and also throughout these 3 days, and the implications for the human bias. Potentially, there's a case, I think, for saying once you've decided what the right action to do is, almost taking that out of the hands of humans and providing some kind of automation of that. And that's quite an interesting concept, particularly in the context of regulatory compliance, for example. But I think where I struggle is where machines can reliably identify what's ethically salient, or at least you might be able to train a model to do that, but almost certainly it's going to produce outputs that are quite wildly different to human outputs. So I think that's the area of most difficulty when it comes to automation, in my view.
We've talked a lot about concepts and we've talked about the ethical considerations, judgment, whether or not we can automate it. Tamara, is there a way that, or can you provide an illustration or example that could actually bring this to life and make it more tangible and real for us?
Yeah. I mean, we've been sort of talking about this between ourselves quite a lot, and there's obviously all kinds of examples we could use. One of the ones that I think people found quite useful was consideration of decisions about our health, medical decisions, because we're all very focused on that, especially at the moment. And just about the use of AI in relation to, for example, the allocation of medical resources, or which treatment pathways to put patients into. So, when a patient arrives in hospital, the staff have got to decide, how that patient is going to be treated. They're going to admit them to hospital. They're going to be an outpatient, or they're going to go home. They're going on a normal ward, a high dependency ward, into ICU. Which medicines are they going to receive? They're going to get mechanical ventilation, CPAP, or nothing. I'm obviously thinking here a little bit in the COVID-19 context, but it applies much more widely. Now, in an ideal world, there would be enough beds, medicines, equipment for everybody. Obviously, in the real world that we live in, that's not always going to be the case. But in any event, even if we're not in a crisis situation or a situation of overt shortages of equipment, staff, etc., we're still always decisions to be made. There's many decision points as to what's going to happen to this patient, and the decisions at the moment are that they're made by medical staff, and in the end, that's a judgment call. And assuming the staff are acting ethically, there's going to be a whole range of factors that staff are weighing up. In the COVID context, things like their age, their ethnicity, the severity of their symptoms, what are their underlying health problems, and the availability of beds, equipment, and so on. Now, personally, as a humble lawyer rather than a technical person here, I can't see in principle why a well-constructed AI system couldn't make some of these decisions, or at the least at the moment make recommendations to a medic as to what sort of treatment pathways people should be put into, and whether or not, how they should be treated in various ways. I mean, why wouldn't an AI system be able to help me with that? It seems to me ideal that it's the ideal application of something like an AI system, because an AI system, it's not hungry, it's not tired. There's huge amounts of data that it can look at, that it can take account of, that it can look through previous results for patients like this, and in theory, it should be able to come up with, you can call it a judgment if you like, but really it should be able to just weigh up all those factors and say, well, look, actually, for this particular patient, these are the most likely outcomes, and could probably give degrees of confidence around those. And at the very, very least, that's going to be hugely helpful, I would have thought, to medical staff, even if they want to overlay their judgment on the end after that, and perhaps sometimes override the systems. Sorry, that's quite a long answer.
Yeah, but it's interesting because it's a very stark example of looking at the ethics of a decision about, using the COVID example about, treatment, which patients to see, what's the ultimate outcome. I guess the thing that I wonder in terms of using a completely automated approach and using AI to assess the ethics of that is, is there a difference when you're talking about life and death versus something that's more, procedural or operational, in terms of that could be something that's more bureaucratic, in terms of who gets seen first in the, or which hospital bed are you assigned to? Mikael, do you have a view on that?
I think it's a very interesting question. I think it partly does depend on the circumstance, but a lot of it depends on your view of ethics. So if your view of what's right, and there is a school of thought on this, that you should be maximizing, the objective is to maximize happiness and minimize unhappiness. So you're really just looking at primarily the consequences of decisions, and weighing those consequences against each other. Then that does, and that's typically something that machines are better at than humans. They can take into account a much broader range of data and execute it much more reliably. As Tamara said, machines don't get tired, and so that's a potentially fertile area to explore if you believe that the main target should be ethical consequences and some kind of value judgment on that. I think that the challenge comes in where the way in which we live our lives is not that. We are very used to justifying what we do, not just in terms of what we do, but actually how we do it and why we've done it and why we've taken decisions and providing reasons. So if you're looking at the sorts of decisions, particularly those that are going to have implications for people's lives, when it comes to the question, well, why was that decision taken? And the answer is, well, the AI said it was the best decision. Then that's unlikely. It's not likely that's going to be satisfactory and be anything like something that can be trusted by people. So I think the provision of reasons is a really important part of any ethical decision, and being able to explain why a decision was taken, which is typically something that machines are not very good at doing, at least doing in a way that's intelligible to humans. So I think that's the really important thing to address if we're going to develop systems that are worthy of trust and gain trust, particularly when you're using them in contexts that have big implications for people's lives.
Haitham, I'm curious, when you were doing your presentation, you talked about the certifier proposition, and then you look at some of the tools that you're developing at Huawei. Are there any areas that you sort of see that actually you can't automate and use the AI to measure, or do you believe that actually we can build those tools and automate it completely?
Yeah, that's interesting. So I mean, first of all, in answering this question, I think it's worth making a distinction between where we are today and where we're going to be 20, 30, 50 years from now. Like, I do not think it's all right or it's right to say that, oh no, this cannot be automated, we cannot do that, given the current status of AI or machine learning. So to me, first of all, my view does change And the reason for that is because it's so hard to embed some form of morality or value inside an AI system. And why is it hard to do that? Because partially it's very hard for us, a human, to agree on a unified concept of morality. Like, what's moral to me is different than what's moral to you, and vice versa. So there are really three directions we're seeking here. The first one is either we're going to try to maybe crowdsource that. So, like try to, do some experiments where we try to extract what ethical or moral behavior or values for a human mean. And that's one way to do it. But that's really hard because it's really hard to devise such types of experiments. The other one is, just have an AI engineer coded directly into the system. And that's really hard to do. That's kind of impossible to do simply because we cannot agree on what morality means. And I think the third one, which Mikael touched on as well, is a bit more towards transparency. And that's where we're going. I mean, if I look at machine learning a couple of years ago, before the deep learning era, models were very understandable to humans. If you look at decision tree type of models, right, it's really simple. You can understand why the model has performed a certain decision. The problem now is that in deep learning, things are becoming a black box. And that's partly what I tried to argue against in my slides, that we should enable this transparency. So there's a lot of research trying to distill deep learners in decision trees, or trying to distill deep learners in first order logical rules, that they are trying to improve the transparency of this learning process and the decision made by the machine learner. So of course we're still at early stages, but I think we're going to get there given enough time, right? Like nobody's saying today we're there, but also I think it's not right to dismiss where we can reach given enough time.
Richard, do you have a perspective? Are there any red lines for you in terms of where machines can never go?
So I think we need to distinguish between things like the explainability of the machine and the decision, and the consequences of the decision. So, I mean, we were just having a conversation there around explainability and transparency, and the rights and responsibilities, etc. But and it is possible to do things like model deep learning systems with decision trees. I mean, you take a performance hit, but if you wanted to interrogate a sort of black box AI, you can create a decision tree, then interrogate like how it's taken. And that's exactly how we've trapped things like racist AIs in the US legal system, is through that type of modeling. And so when we're looking at like, when should a human always be in the loop? I think it is about the consequence of that decision, and thinking that because where humans are better than machines is not in consistency, it's not in the ability to handle complex information per se. I mean, we talked about COVID earlier. It's instead in being able to deal with things that require compassion, empathy, the ability to handle things outside of a particular model. And if you think about the areas where you're going to be unhappy with a machine taking those types of decisions, they're things which involve, your ability to live your life, your liberty. It's not like which advert gets served up, it's whether or not you go to jail. And it may be that in the first pass, you're happy to take the consistency of a machine in making the recommendation because, there's been studies. There's a study in the Israeli legal system which showed that judges, the best time to be seen by a judge is just after they've had breakfast, because then they're most likely to be lenient. And the worst time is just before lunch because they're a bit hangry. So they're going to lock you up. And that's a reliable pattern. Like it happens every day. There's a little bit of noise in there, but it's a reliable pattern. I'll take the machine that is consistent all day long for the first pass. And then if I think there's something special about my case that requires empathy or requires some compassion, I need them to understand that I have 2 kids, I'm the primary carer, and that this is going to be a big thing. And that's outside the model that the AI is trained on. Then I want some sort of appeal mechanism that then goes to a human where they can understand some of those things that are outside the model. So for me, we need humans where you need those type of attributes, those human attributes, and where the decision has so much moment on someone's life that we feel like as a society those things should be done by a person.
Well, it's interesting. I want to touch on something that you just said, which is about the fact that you actually prefer the consistency of decision making in a machine in dealing with judgments. And so, you're not weathered by, how tired you are, what you ate, what kind of mood you're in. One of the things that's, huge, a big source of discussion and debate is always about bias and whether or not, by nature of humans being involved in both creating the machine, selecting the data, etc., there is an inherent bias that needs to be detected. And I guess, Mikael, I'm interested from your perspective, are we ever able to remove bias completely from a machine and almost get to that state that Richard just talked about, that where the machine is always objective in the decision making?
Yeah, I think it's a really, I think Rich makes a really, really interesting point. I guess my starting point would be it's better to be right some of the time than it is to be kind of wrong, systematically wrong all of the time. And that's, I suppose, one of the risks when we think about automation. And the same is with bias, that we know that we know that humans are biased, but we have these biases because otherwise we wouldn't be able to navigate the kind of very complex world that we live in. We simply wouldn't be able to process all of the sensory information that's available to us, manage all the uncertainty that we have to manage in living our lives. And so those are the reasons that's the reason we have biases as humans, is to help us process this information. But it's a kind of known quantity, and we're very used to kind of interrogating that as a society, although very much not haven't cracked the problem by any means. But I think it kind of goes back to I suppose the point that I was hinting at earlier, and which we've kind of developed in this conversation. It's that how do you, in the first place, recognize there's a problem or likely to be a problem? We tend to be quite bad at that as humans, but we do have frameworks for doing that, and we do have the ability to see when something's right or wrong. Perhaps we even feel it's right or wrong before we know why. The question, when it's happening within the context of a kind of machine learning process, is at what point is human alertness prompted? And Richard's idea of having some kind of control whereby you assess the nature of the judgment and the decision, and you give some kind of appeal mechanism. I think that's a really appealing idea, and it'd be interesting to develop that further. My query on that, I suppose, is that where a lot of the decisions are taken, I suppose, within the fabric of a much broader chain of decisions. And if you're basically taking the output at the end of that chain, if you're the patient, or if you're the customer, or if you're the person who's denied access to credit, being able to unpick actually what decision are you actually really appealing, where you've perhaps got quite a complex process of judgments that's got into that. And I think that's something that's kind of really important to understand, also from a governance perspective, right? So if you're going to use AI increasingly, and by the way, it's an assumption that we always make that AI is going to be used increasingly, in order to address that, you're going to need to layer on additional complexity. I think we have to call that out. These are all choices that we make as a society. There's no kind of inexorable law that means that all has to happen, but it does feel like an inevitable direction of travel. And that's not to understate the potential benefits of that. But I think, from a governance perspective, you've got to, if you're the senior leader in an organization, responsible for AI development, you've got to be pretty sure about what are the potential consequences of this, what implications does it, what effectively are we as an organization delegating to machine learning algorithms, and is that justifiable? What might be the issues that arise? And unless you can reasonably confidently answer that question, how will you know if it's trustworthy?
Well, Haitham, let me pass it to you, because as you start to develop these solvers and you start to develop some of these algorithms to deal with detection, robustness, safety, some of these things, do you believe that you can get there with, and address those things that Mikael has just raised?
Yeah, I mean, in short, yes, I do, and I think, okay, so the way to do this, I think it's important to note two things so far we have discussed. One thing is the human bias, which is going to always be there, and the other thing is how is this human bias embedded inside a machine learning pipeline? So the way or the reason these machine learning algorithms are becoming biased or unethical is because whether explicitly or implicitly, we're putting our biases inside different aspects of that pipeline, inside different places in that pipeline. So for example, implicitly, you might be isolating a group of people to gather data, and then that automatically creates bias against the other group of people, and so forth. So for me, the way we can handle things like that is going automated, really. I believe the way we should handle that is by allowing machines to design their own loss functions. So in other words, if we are able to figure out metrics, right, and this is on our shoulders as a humanity, to figure out metrics that describe what values mean, that describe what morality means, etc., etc., then in fact you can embed these losses inside a machine learning algorithm and ask it not only to flag out biases that has happened in your process, but also adaptively correct for these biases. So for example, if your GAN system or variational autoencoder or whatever it is that's generating your images is given an additional concept of like look for bias and generate data that removes the skew in your distribution, then we can ultimately reach a place where we have unbiased data really from that specific metric. Now the question is, oh, can we define this metric? I think that's a question beyond this this discussion, because as Mikael just said, there's a long history studying things like that. So I believe, in short, yes, we can reach there. But of course, I mean, we also see that people are starting to work on things like that. For example, there are methods that do self-supervised learning today that are already, trying to generate autonomous images for a problem. There are methods that are capable of generating images from just noise. So all these, when given the right metrics, they should be able to generate a bias-free data. So to me, as long as we remove the human farther and farther away from the pipeline of machine learning, the less biased machine learning can become, pending the right metrics to embed in this pipeline.
Tamara, I'm curious with your lawyer hat on. When I listen to both Mikael and Haitham talk, and they're talking about removing bias, creating models and algorithms to start to address that, to me, that's providing more transparency, versus what was in a person's brain and why did they make that decision. I guess, my question for you with your lawyer hat on is, isn't there something to be said about, that there should be a more favorable weighting to the fact that, using an AI model to assess ethics and some of these judgment factors, there's consistency, transparency, more robustness than sort of the human determination?
Yeah. I mean, it's a really interesting question, and I mean, again, with the lawyer hat on, if I bring it back to, say, the ICO, so the Information Commissioner has, as I'm sure has been discussed outside of this, is put together an AI auditing framework with a lot of very, very detailed guidance to help organisations decide how they're going to make AI systems in an ethical way, in a way that's compliant with GDPR and the UK Data Protection Acts. And it's really worth reading. It's only in draft at the moment, but it's just it's a great document, really full of practical examples of how these systems can be made to work. But I mean, generally speaking, regulators and the ICO is a pretty pragmatic, realistic, real-world regulator, and they're often very concerned, not always about did you come to the right decision, did your system create exactly the right decision in whatever the context is. A lot of what they're about is actually making sure that you have put the processes in place but you've thought about it all carefully. You've taken the data protection principles of transparency, fairness, accountability, data governance. You've taken all of those things into account, and you have to do it in a pretty formalized way in order to be compliant. What is very important is to demonstrate that you've been through that process, you've put the systems in place. And I think if you've got a really good AI, what you might call an AI oversight system, which is able to really help you with the management and governance of what I would call the underlying AI system, I don't know this, but I would guess that a regulator is going to be really pleased that you have gone into it to that degree, that you've taken it seriously enough, that you have got a system that is helping you to exercise better oversight over what's there.
I'm just conscious that we're starting to run out of time, and Richard, I want to give you the chance to sort of have the final word. With the work that you've done before, I want to get your thoughts as to, with the new frameworks coming in, the tools that are out there, some of the ones that Haitham described, what does the future look like, and where do we go from here?
So I think that one of the real tricks in this and in trying to build these unbiased systems is getting the right evidence base and getting the right data together. And that's we're only going to achieve the scale that we need to be able to have truly unbiased systems if we can find mechanisms for people to collaborate on the evidence base, collaborate on the data that underpins all of these systems. I mean, you can see that a bit in some industries that are starting to come together and share data in things like data trusts, like legal mechanisms for getting collaborative data together on things like medical records, and also in things like more prosaic industries like construction. So I think that type of mechanism. But just to pick up on something that Haitham mentioned about like getting synthetic data and getting huge data together, that's not going to be the be all and end all of removing bias. We need to be very conscious about the way in which data is collected, the first sets of data are collected, because it may be that there is something in the experimental method that means that there is some latent bias there. I mean, there's some fantastic sessions at CogX talking about this, but there's also some fantastic books and research into this, particularly like the work done by Cristina Perez. So we should be alert at every stage as to how the bias can creep in.
Thanks, Richard. Well, I want to draw this session to a close. This has been an excellent discussion to really talk about something that can be quite a debate about using AI to automate the ethical considerations around AI itself. For those of you who are watching and want to participate in the debate, we're going to move to another stage to answer questions and answers from the audience. So we'll continue this discussion. For those of you who are continuing on the ethics stage, there is a session coming up immediately after this called Privacy Not Included. So stay tuned to that. I want to thank everybody for participating in this and thank the audience for watching us. Thank you very much.
Want access to more CogX videos? Subscribe now for free at cogx.co.